Okay, so here we are in section 6.3, and it's a short section, but it's about simplifying complex fractions by simplifying the numerator and denominator. And we've kind of done this a little bit, but let's look at what a complex fraction is. A complex fraction is a quotient having a fraction in the numerator, denominator, or both. As you can see in each one of these examples, we have a fraction here in the numerator here, 2/3. We have a fraction in the denominator, 4/9. So we have a fraction over a fraction, basically. And these are all examples of complex fractions. And what we're going to talk about is how to simplify them. So here we go. Objective 1, simplify complex fractions by simplifying the numerator and denominator. So the step 1 is to simplify the numerator and denominator separately. Then divide by multiplying the numerator by the reciprocal of the denominator. Remember, when we divide fractions, we flip the divisor and multiply. So we're going to use that concept here to do this for these complex fractions. And then after it is all over with, you simplify the resulting fraction if it's possible further. So here's one out of the homework here. Once again we have 2/6 over 17/18. So the first thing we do is write it as a division problem. And then now what we're going to do is flip the divisor 17/18, which is the reciprocal, and then multiply. But we can simplify this further here. First off, we notice 6 will go into 18 3 times. So we'll simplify that out. So the 6 becomes 1 here, and the 18 becomes 3. So now I just multiply across here. So 2 times 3 is 6. 1 times 17 is 17. So that was our first simplification of a complex fraction. So here we go with another one that's a little bit more complicated. We've got y plus 2 over y divided by, or a complex fraction. We've got a fraction in the numerator and a fraction in the denominator. So the first thing we do, it's already simplified down, so first thing we do is write it as a division problem. So we've written this as a division problem here. So now we're going to flip the divisor. So we put 3y in the numerator. We put y minus 2 in the denominator. Now we just look for things that'll cancel out. What'll cancel out is the y. The y will cancel out because that's common between the numerator and the denominator. So we just kind of rewrite this. We've multiplied across, and then we canceled out the y. So this one is simplified now. It's into its simplified form there. So we're going to look at another one of these here. We got k plus 1 over 40k divided by, or complex fraction, 4k minus 3 over 8k. First we write it as a division problem. Then we flip the divisor. Now 8 over 40 will reduce down to 1/5, right? So first the k will cancel out, and then the 8 over 40 will not cancel, but it will reduce. So the 8 becomes 1, the 40 becomes 5, and then we just multiply this across here, and we've got our simplified fraction here. We could write it this way right here by distributing the 5 there. And then our last one to look at here, we have another complex fraction here. And what we do here, first we write it as a division problem. Now there's a couple things we can do. First, this 12x minus 48y, we can factor out at 12. But first let's go ahead and flip that divisor. Okay, so moving into the next step, now we're going to factor out that 12. So we got a couple of things going here. One, we've got x minus 4y in common here. So those are going to cancel out. Then we got 7 over 28. That will reduce down to 1 over 4. First off, x minus 4y cancels out, and then these will reduce. So we end up with a 4 in the denominator here, a 12x in the numerator. This will simplify further. 12x divided by 4 gives us 3x. So that's it for simplifying complex fractions.